So since I've started over here, I'm going to, I think I'll just put it over here. Gotta do it. The process of statistics. When we say I'm going to use a sample to measure the population, there are two ways that that happens. The first one is using a confidence interval. We've already talked about that. And current research says this is what you should be doing confidence intervals. Because with the confidence interval, you're just looking at the data that you have, and you're just using the data to get the number. And then you can compare it to whatever you want. You can do whatever you want to with that number, but you're just getting the number from the sample about the population. So you say, this is what my population number is. However, traditionally, for the past, I don't know, 50 to 100 years, people have been doing something else, which is called hypothesis testing. Hypothesis testing does not actually measure a number. Hypothesis testing compares our population with a standard number. So that we have to have something, some kind of a number out there that is told to us to say, this is the number that's being used. And once we have our number, okay, and then we have our measurement, then we say, okay, I want to know if it's different. Can I prove that it would be different? So what I'm going to do right now is I'm going to upload to Blackboard the notes for this particular section so that you don't have to worry about missing anything that way. And that is going to be hypothesis testing. So under resources in Blackboard, you have a section that says new notes under construction. And at the bottom of that, you have hypothesis testing. So it looks like this. We want to prove a difference. We want to say our population is different from a standard number, such as when we talk about people with, let's say, calcium levels. And let's say that, and I'm just making this up, the national average is 120. You Western Technical College students have low calcium. I want to know that. So how does this work? Well, I know that if I take samples, I know that there's going to be variation among those samples. And so the question will be, can I figure out how likely a particular sample could be? I know my samples, some will be higher and some will be lower. But if they're way high or way low, then I might say, that seems to give me evidence that Western is in a different place, that they have different numbers than what the national number would be. Now, I certainly could not try to prove that Western Technical College has an average of 120, because my samples are always going to be different, right? I'm going to have some samples above or below, so I can't know that it's actually 120. But I can prove if it's significantly different from 120. And so then I know what to expect from my samples. And if I know what to expect, then I can identify an unusual sample. And so the concept here is, if I get an unusual result for a sample, then I was wrong in assuming that they were the same as the national number. Remember, if I have something and I'm doing X bar, if I have a mean right here, let's say this mean was 120, and then I went out here and I said, okay, my sample came out to be 140. Well, that would be unusual. And so then I would say, maybe Western students don't have an average of 120. Maybe it's higher than that, and that's why I got this thing out here. In a similar fashion, let's say you were going to a particular restaurant, and they said, oh, well, the average age of people that go to this restaurant is 30 years old. And you walk in there, and everybody's 40 years old and over. It's like, no, you're wrong. It can't be an average of 30, because look at all these people here that are older. So you say, if this particular sample is substantially different, then the information that I was given is not correct. So if I look at this and I say, this particular sample is at 140, then that means I should not have thought they were the same as the national. It's probably higher. Now, what we're going to do, we're going to start talking about the proportion. We're not going to do the mean, we're going to do the proportion. So it's actually going to be a p-hat here. We're going to have a bunch of p-hats. And we're going to assume a certain percentage here, let's say 30%. And we're going to compare it to a sample number that we get out here, like 40%. And we'll try to answer the question, is this an unusual value? Is this something we would not expect to happen? If it's an unusual thing, then we say, oh, so I assumed it was 30, but that's not correct. It's probably higher than that, based on the fact that it's unusual to have a sample that's that high. So,
can it be low too?
Sure. I mean, if I get,
go either way.
Yeah, yep. If my sample came out low, then I would say maybe it's too low, right? Yep. Now, in order to make this happen, there's a number of statistical traditions that we're going to use here. So there are going to be two types of decision that we can make. And these are listed on here. The first type of decision is that I can prove a difference. I'm able to say that there's something going on here so that I can prove something is different. This is our goal. We want to do this. And what we say, I'm going to write this up here and then explain it later. There is evidence to prove H1. Okay, that's how I do that side. What happens on the other side? On the other side, we say no decision. The sample could be random fluctuation. What do we mean when we say fluctuation? Somebody describe what that means.
You can go up or down.
Could be up or down. So the fact that the sample is either higher or lower, it could just be a random thing because it's a sample and they always change. So then if it is in this situation, we say there is not enough evidence to prove H1. Now, I'm telling you that it's H1, but in our textbook, they actually use HA. H with a little A down here. Most textbooks use H1, so whatever. You'll see it both ways in research, but most of the time it's H1. Now, how does this actually work? In the traditional way of doing statistics, what we're going to do is we're going to establish what's called the null hypothesis and the alternative hypothesis. The null hypothesis. This is going to have an equal sign and it's going to have a standard number, some kind of a standard number that says this is what we think it's actually true. So, as I have listed here in the notes, we could have the mean equal 57, or a proportion is 25%, or a standard deviation is 3.6. Any of those things could happen, where we say this is some kind of a standard number that's told to us as being important. So, yeah, we'll go through an example of this in just a minute. But then, what we want to prove is called the alternative hypothesis. We want there to be some difference. So the alternative hypothesis is going to have an inequality, which would be possibly less than or greater than. And this is the thing we're going to try to prove. We want to prove that there is a difference between our population and some standard number. And so then we're going to have some direction of the difference, either less than or greater. Now, as I mentioned, what we're talking about here is that the samples are varying. The samples will have some variation in them. And we want to have it be bell-shaped. So if we say that it is somehow out here, one way or the other, then we would have a tail. And this would be the probability here. This would be the probability that we would have a particular sample. The name of this is called the p-value. And most of the time it's a capital P. So the p-value is describing for us what are the chances of getting a sample that's way out there. As you'd mentioned, it could be to the right, which would be greater than, could be to the left if it's less than. And so then what we're going to be looking for here is how this p-value compares to alpha. What did I say alpha is defined? When we were talking about confidence intervals, what did I say alpha actually means?
The chance of being wrong.
It's the chance of being wrong. So I want this probability to be less than alpha. I want a p-value less than. All right, so we're going to take a break right now for 10 minutes. We're going to come back and we're going to talk a lot more about how this actually works. So that'll be 5:15.
Fraction.